Thank you very much, Christophe, for this long introduction. Yes, good evening, dear colleagues. So normally I should have talked after Bauke, but Bauke is going to give a talk on L5N6 differential disease. I'm not going to speak about differential disease. I'm focusing on L5 today. I will present recent genomic results that have been obtained with a new pipeline that I believe are improving our understanding of the population structure of L5. And I'm also going to suggest a new hypothesis related to the evolutionary history of L5 in relation to human genetics and probably also to cattle history domestication. But to introduce my first slide, I must first quote Antoine de Saint-Exupéry. Antoine de Saint-Exupéry is a famous writer. He's known for The Little Prince, but he wrote in another book a sentence I like very much, which is, and certainly there must be connected objects for the connections to show themselves. And this sentence describes exactly, very precisely what we want to do. Building trees, connecting isolates with different histories, whether epidemiological or historical. This is an example of the type of tree. This one has 16,000 genome. It was built with the first version of our pipeline. And we are going to focus today, especially on this branch here in brown, that is L5. I must also quote another man, an anthropologist, a paleontologist, sorry, Yves Coppens, who passed away last year. He wrote, for the old proverbial said, always Africa brings new cases. And he's the man who is among the discoverer of Lucy, Australopithecus afarensis, one of the most ancient hominids. And actually, this is indeed the case. In a past study, we started to work on Nigeria, and we collected 1,000 Zil-Nielsen positive slides, thanks to our esteemed colleagues and so regretted Professor Luis Cuevas from the Liverpool School, who passed away, unfortunately, recently, and Lovett Lawson from Nigeria, who was Mr. Stop TB in Nigeria. And thanks to these two colleagues, I could start to work on all the Nigeria, and we succeeded to get some specific information showing that L5 was more prevalent in the southeast, as shown on this map. L5 is in blue here. And this is in the Igbo-speaking country, but we don't know exactly why these strains are more prevalent in the southeast of the country for the time being. Another byproduct of this study, again, something that Antoine would have liked, Antoine de Saint-Exupéry, is that we are creating clusters in this study between Nigeria and USA. Thanks to polytyping, we could link, probably because of either historical, we don't know if it's ancient or recent migration from Nigeria to USA. And you know that normally Mycobacterium africanum does not transmit very well from patient to patient. So this history is quite interesting too. So going to the phenotype, Mycobacterium africanum, when it was described in 1968, it was showing some intermediate characteristics between those found in MTB and M. bovis. And we are going to see why it was showing apparently these intermediate characteristics. Especially the colonies, they might look sometimes either eugonic or dysgonic, and we will try to understand why. In the 70s, when the 4 Africanum types were described after Dakar, there was Yaoundé, Rwanda 1, and Rwanda 2. And these 4 names were, actually they were given based on geography, but it was also shown that they were inequally distributed in Western and Central African countries. Other information was Africanum was not found in East Africa, not in Maghreb, and not in Egypt, and that no African types were isolated in Asia or America. Actually, Africanum was found in Egypt, but it was found in Egypt in the past. We have been doing in the past a study with an anthropologist, a German anthropologist, Albert Zink, and Albert Zink, studying some mummies, has been showing that in most ancient kingdom of Egypt, there were indeed probably some Mycobacterium africanum based on polytype results. So going back to this phenotype of eugonic or dysgonic, actually in 2005, there is this paper by Keating and colleagues that was showing that Mycobacterium africanum is a natural mutant for two genes, two important genes of the metabolism, pyruvate kinase and glycerol kinase. So that's explain why you have, everyone who has been growing Mycobacterium africanum knows that you have to supplement with pyruvate if you want to obtain organic growth. So this is a slide that Bauke is going to present, and I really like this one because it explains us why there was this taxonomic confusion about Mycobacterium africanum in the 70s. Actually, the Yaoundé type probably correspond to is L5 today, and the Dakar type correspond to L6. But there are two other types, 4.61 and 4.62, that have to be replaced in the MTB complex, and because they are only according to they look like Mycobacterium tuberculosis stricto sensu. And actually, this explains in Yaoundé, so in Cameroon, where you could find these quite taxonomic confusion. There are also some specific region of deletion and specific spoligotyping signature. As early as 2004, we were trying to improve spoligotyping in Mycobacterium africanum, and by adding spacers, 25 more spacers, that comes from this CRISPR region that is a scar of former relationship with mycobacteriophages. And among these 25 new spacers, there are some that are bovine and some that are strictly human. So we increased the discriminatory, but at that time we were doing spoligotyping on membranes. And of course, you could not do that very easily, 68 spacers. Now, using multiplex spoligotyping, it's much easier. And in 2014, we changed era because now we can define Mycobacterium africanum based on SNP, single nucleotide polymorphism. And we see, thanks to the work of the London School of Hygiene and Tropical Medicine, that you can have at least 370 SNPs specific of L5, and you have also many SNPs, more than 200 specific of L6. The work we have been doing, this is the same picture I show you in the former slide, was confirmed by a work done at the Pasteur Institute by Louis Attès in 2018. And I really like this study because it is asking the right questions about Mycobacterium africanum. It suggests that actually there are at least two sublineages, 5.1 and 5.2, and that one region of deletion whose name is RD711, this region of deletion that was supposed to be specific of L5 is only specific of a sublineage of L5 that is lineage 5.1. And with an association, strict association with this lineage, we find the specific spoligotype, sorry, I have to go back, the specific spoligotype that is linking here the loss of one IS6110 to the disappearance of this block of spacer here. So when you are doing classification of unknown genomes population, you have two ways to do that. You can either use a supervised way or an unsupervised way. And in this paper that was published by an Indian group this year, there is a suggestion that based on a set of around 200 genomes, there are at least 6 sublineages in L5.L5. And these 6 sublineages, this is the most likely statistical number of population that were found in this data set. And the number of SNPs is quite high, more than 972 core SNPs, even though in this paper, the true informativity of the SNP does not go into very much detail. And this is a paper that is one of the most impressive genetic diversity studies that has been done so far on L5 and L6. This is a paper that was published last year by Mireia Coscola. And in this paper, she shows first that there is a new sublineage of L6 that is found specifically in East Africa. And this creates at least a link between L6 and L9, between East Africa and Central Africa. And also this paper describes 7 sublineages inside L5 and 9 sublineages inside L6. And last but not least, in our two or former result, I have to mention the paper that was obtained recently in Bauke's lab that is using another genomic method, PacBio. And with PacBio, you can get much longer reads of sequence. And so you can find some genes because you are doing de novo alignment. So you can find some new genes that you don't find if you compare your genome with H37RV. H37RV is good to locate SNPs. However, it creates also some limitations in gene content assessment. So these results show us that there are at least 60 genes that could be differential between inside L5 that can be gained and lost, and probably there are some physiological function that goes, of course, with the loss or the gain of these genes. If I am dealing with population, I must mention something that you probably know already. It is that L6, L5, and L1, it must not be considered as africanum, but it's an ancestral lineage of Mycobacterium tuberculosis. They have very, very different geographical distribution. And keep in mind these heat maps, because actually they are built on 100 studies totaling more than 20,000 isolates. And I will come back to these maps in my last slide. So why should we study the number of lineage, and why should we study the genetic diversity? So if you look back at the data set size, most of the time people are trying to look at the bioproject that contains Mycobacterium africanum. However, this is a supervised way to do things. And actually, they did not find a very important number of lineages. We believe, using our last study on 433 genomes, that there are maybe as many as 48 lineages that represent historical transmission of TB in Africa. So now I have to speak a little bit about methodology, even though it's not my cup of tea. So the TB Annotator project, which is our new pipeline, has started 3 years ago based on an encounter with a mathematician and computer scientist, Christophe SOLA, and with the help of Guylaine Refrégier, who is a population geneticist. And to this project, we now have a PhD who is a real geek guy who is doing the new development. And now we can dig into 100,000 genomes very easily and try to transform all this raw material into medical knowledge. So this was the first version, and second version, I will have no time to go into too much detail, but we started from 360 L5 genomes, and now we have as many as 460. So you see that the relative increase is very slow in L5 comparatively to the increase in genome, which is excellent for the other lineage, but unfortunately not enough for Mycobacterium L5 knowledge. So this is the type of display we have in our pipeline. We can screen for various characters. We can make some queries on specific SNP positions, what we call the SPDI, and we can then select a group of strains based on the IS6110, based on the region of differences and so on. And when you have selected a set of strains, you can export this set and you can re-import it into a graphical interface that allows to play with the graphic and the data. So by selecting with some keys, you can play and try to select exactly the clusters that give you the most specificity. And this is how we are defining the cluster, which is one of the best way to do, I guess. And here is a tree that is built on these 100,000 genomes that now contain 430 L5. And this was done also thanks to a project that we are doing, a follow-up project in Nigeria, where we are sequencing some isolates from the northern Nigeria. So we will focus on this L5 branch. If we do a close-up on this branch, and if you try to analyze how these branches are formed, you see that if you use the classical SNPs that are defining L5 according to the SNPs by the London School of Hygiene and Tropical Medicine, you select 430 genomes. And with our new SNP, with our new definition, we select 3 more. But what is more interesting is that we have a couple of isolates that seems to be at the root of the emergence of this lineage. So probably we think that at least the three strains that are found in the London School database, they represent either Archeo L5 or Proto L5. I don't know how to name it for the time being. And why do we have to take care when defining a lineage with SNPs? It is because sometimes you may have a lot of false positive or false negative. And also you have to look at SNPs that cluster together if you want to detect also something that is relevant. And here we have 433 genome lineage coming from all over the world that share 35 SNPs in common. And there was one good SNP in the set of Napier. It is this one, 1505805, that has a precision of 1, which means that there are 0 false positive and false negative. So this is a tree, and we have no time to enter into the detail of this unrooted tree of L5, but it shows you very clearly that there are many more lineages than 8 or 7. We can count here at least 25 or 30 sublineages. So I don't have the time to enter into detail, but to cut a long story short, here is the updated tree on L5 that also is taking care of the former definition, the definition by Koskola in red and the definition of Balamurugan in green. Another very short observation is the fact that sometimes we can observe convergence, genetic convergence. Here is an example on an helicase gene where we find the same mutation independently on 2 sublineages, including 1 sublineage of L5. So just to go in review, here is the tree and here are all the lineage, 4.1, 4.3, 4.4. And all of these lineage, they definitively have some lineage in which we could dig inside. For 5.2, 5.3, and the 5.3 actually is a sub-branch of 5.2, but we have a true newly defined 5.3 here that have no character in common with 5.1 or with 5.2. So now I'm ending my presentation with these final hypotheses on how probably L5 may have reached Africa. If you look at this map that shows a superimposition of cattle introduction into Africa, and this map is extracted from this paper, that is a paper that is describing lactase persistence in Africa and the complex history of lactase persistence in Africa, we are now understanding that we are dealing with 2 histories. First, the history of both Taurus and both Indicus introduction into Africa, and as we see, they follow different paths. And also, secondary, the history of migration, relative migration of the nomads, the herders, and the sedentary Africans. So keep in mind this, and you see these 2 spots that are very interesting, these 2 red spots, because they are showing that both Indicus was introduced in Central Africa and the Gulf of Guinea, and both Indicus was also introduced in the western boundary of Africa. So this could correspond to L5 introduction, and this could correspond to L6 introduction. So if we keep this, and if we look at our heat maps, we see that we have a strange superimposition of presence of these 2 relative sublineages inside Africa and with their phylogeographical history specific. So we don't know yet exactly the type of mutation rate. If we have a low vertical transmission of an endemic disease and slow mutation rate, or if we now also have today active ongoing transmission of an epidemic disease with faster mutation rates. So trying to retrace the exact timing of introduction is something difficult, but we have what the people working on both genetics tell us. They tell us that there were 2 separate introductions, at least, of both Indicus, and this is related to the domestication of cattle in the Indus Valley, and both Taurus, this is a domestication in the crescent, fertile crescent. So you see the pathways of the 2 are very different, and probably this could be linked to a population that were carrying with them these bacilli. And of course, this does not preclude if there was a human to bovine or bovine to human transmission. We notice the work of Roland Broche that probably it is human that contaminated cattle and not cattle that contaminated human. Just to end, and there is no monotype sort found, so you can see the oligotype as they appear with black and white square, but we have a lot of specific oligotype signature, and this oligotype signature in this new sublineager, they are always associated to specific IS6110 insertion site, to specific region of difference, to specific SNPs, and to probably also specific gene content. So I hope I have convinced you that there are many more than 7 or 8 sublineages in 2 and 5. And to conclude, Mycobacterium africanum L5, L6 are likely to be two ecotypes of Mycobacterium tuberculosis complex with totally different niches, linked by speciation even, that could be linked to historical Bos-Indicus introduction to Africa, one or many times between 2,000 years ago and more recently. Mycobacterium africanum L5 is made up of more evolutionary clone than currently described. And the nature of these clusters, whether epidemic or historic, can now be better investigated. And the chronology of emergence between all these subclusters can be understood and traced back thanks to our pipeline that is giving much more information than only by the ones that are using SNPs for the time being. And there should be much more genomic studies that should be done on L5 and L6 because we have only 430 public genomes of L5, and this is indeed ridiculously low as compared to the weight of this pathogen in Africa that still remains at quite high prevalence in some specific areas. And I want to thank all the people of these that contributed to this study, and also many collaborators that have been participating to this type of genome gathering. Thank you very much, and I thank you for your attention.